Guten Abend, Damen und Herren. And like most immigrants in Berlin, my German ends there. And like Mitsuaki said, I'll be talking about software testing. And actually, this presentation is part of a long article series I already wrote and started to publish on Medium. I will present the core idea, and I hope if you find it interesting, you can go and read it. And like some of you did in the workshop, you can come and ask me. So this is the basic agenda. First, I will try to explain what's the problem I'm trying to solve, what bothers me, and then I will present you a model that I developed, and afterwards I will try to explain how I use that model to solve that problem. So, main source of pain. Testing is one of the most controversial topics in development world. Not because it's complicated, it's because it's not standardized. Everybody has a different understanding of testing. Even the unit tests you heard most have several definitions. Like literally, if you check testing types, there are hundreds of them. And integration tests, oh boy. For instance, we always say integration tests are checking if components are interacting with each other correctly. But what if a component depends on 3, 4 more components? And what if those components requires a database, mail server, or web server? And over time, it becomes overwhelming to write the test scenarios. That's why I wanted to solve this ambiguity, and the solution came from stories. If you're into storytelling, maybe you heard Hero's Journey. It's a template that you created by observing like thousands of different stories and finding common patterns in heroes' journeys, like the same phases they go through. For instance, there's always like starts from an ordinary world, there's a call to adventure, like Gandalf calling you for an adventure, something like that. Then you enter a special world, then you hit to the bottom, transform, change, go back home. And I literally checked, like with every story, this template works. And I thought, like, if we can apply this template to one of the most complex, diverse, emotional things, stories, if we can fit that into a template, why we cannot apply the same thing for the most deterministic thing in this planet, a piece of software? That's why I tried to create a model. Here, I would like to present you the anatomy of the product model. Thank you. Thank you. It's never too late. So this is the anatomy of the product model. It consists of 5 components. I also created this by observing so many different software. So first, what is a product? Product is a piece of software that solves a business requirement. It can be an NPM module. It can be a front-end application. It can be a back-end service. It can be a background service. It can be anything. You name it. And the first is the internal state. Internal state is any information that we store in the runtime created by business logic and can be only modified by business logic. So for JavaScript developers, they are basically JavaScript variables. And the second is I/O connectors. These are the most important component in this model. I/O connectors allows us to make I/O operations. And I/O operation is any interaction that business logic does with the global state to read or write. So, and I/O operations are the most expensive operations since they rely on network, file system, and there can be latency in the I/O operations. And the global state is any information that we store outside of the business logic. It can be a database, it can be a file, it could be coming from a web server. And business logic don't have control over a global state. That's why we have to check the integrity of the information that we are getting into our business logic. And please notice time is part of the global state. Business logic cannot change time. And to give you more context, I wrote down here some examples. For instance, here if the global state is in the application memory, then we access it with the JavaScript API. For instance, using global keyword or process. So I/O operations don't have to be async. They can be synchronous as well. And if they are in the file system, our I/O connector is the FS module, for instance. We are going to fake them in upcoming slides. So the fourth one is the public interface. Public interface is the gateway for your users to use your product. basically. And for instance, for a front-end application, it's the web UI. And for instance, for a React component, it's the properties you accept from your users of your component. And these are just some examples to give you some context. And lastly, business logic. Business logic is the algorithm that solves the business requirement by basically using all these components, if-else statements and function calls. And altogether, when they come together, they create the product. And some of these components are optional. For instance, like if you don't have global state, then you don't need I/O connectors. And if you don't have a business logic, then you don't have internal state. And now, this was the anatomy of the product model. I know it sounds a bit abstract, but I encourage you to look into some software and try to identify these components. After several trials, it becomes really easy. And how do we use this to assign the test roles? Basically, we divide these components into two clusters. And we use a unit test to check everything that is related to our business logic. But since I/O operations are expensive and we want a fast and cheap feedback mechanism during development, we don't test I/O connectors, we use fake I/O connectors. And integration test, we check the real I/O connectors. It's that simple. Like, let me go into a bit more detail. So with a unit test, we provide all possible inputs that could come to business logic from the public interface and from the global state. For instance, here if you see, the only way the business logic can get information is the public interface or the I/O connectors. So if I provide all possible inputs that could come from these places, I can create every logic, invoke every line, every statement, every branch in my business logic by simply providing these inputs. And and at the end, when I check the code coverage report, if I see a section is not covered, that means either I forgot to provide some inputs that invokes that branches, or that piece of code is redundant. And now you can also fake time, math random functions, and if your logic depends on time, you can still test it with unit tests. So basically, anything is related to business logic can be tested by unit tests. And while you are doing that, you have to provide everything through public interface, because the only way that business logic can update or read the global state is using I/O connectors. And as long as the data you provide are transformed and provided to I/O connectors correctly, that means your logic is doing its job. That's why everything in between is called implementation details. They can be changed, they can be improved. That's why you shouldn't focus on implementation details. You should focus on the behavior of your public interface. So this was the unit test. Some takeaways for you, like test only your public interfaces, do not test implementation details, and provide all possible inputs. That's possible. And now with this, what could go wrong? How do we know the fake I/O connectors that we use are working as expected? Or what if the protocol of those I/O connectors changes? With protocol changes, I'm referring to like the response data structure can change, or the order of the arguments can change, or the type of the arguments can change. And in unit test, we will miss it. And this way, with integration test, we check our I/O connectors, and we write a test for each different protocol usage. I would like to explain this with an example. Here you see like 7 different stubs. I hope it's readable. In the first 2 calls, these are some fake I/O connectors that are used in my unit tests. For instance, I have a getUser function. It fetches a user from the database. And here I stubbed it. And in the first 2 examples, I provide an ID value, ID type value. This, the yellow parts you see there as ID shows you the type of the data that you are providing. And it returns a user object. And in the second call, when you provide an input has an email type, then it returns an admin object. Probably admin object has different properties, and that's why these two inputs and outputs are different. These are two different protocols. And in the third call, you see that I provide an ID1 value, but I also provide a second argument. Then I get users with their comments. This is also a different protocol, because the response data is different. And in the, I think, sixth one, you see that I provide an ID type value, ID3, but I get fish. That means this ID3 is an exceptional value for this function. That means even though type is ID, there's this special behavior here. And the same for the last call. Even though I provide an ID type, ID4 value, it throws an exception. That means here I see 5 different protocols. And that's why I have to write 5 different integration tests providing these type of values and using the real I/O connector, I mean the real get user function, create a database instance, and see if I'm really getting this information. And together with unit test and these I/O connector tests, integration test, like pieces of Lego, they complete each other, and this way we can make sure that our logic, we don't release any unintended breaking changes. And some takeaways for you: test only your I/O connectors and write a test for each different protocol usage. So this is the basic idea, and I hope you find it interesting. As I said, if you find it interesting, you can find me around. Actually, this is a very long topic. I tried to summarize in 10 minutes, and thank you very much.